Okay, we're gonna look at kind of reviewing absolute value equations and inequalities here. Here's kind of the question. We're looking for answers that go into this problem. So that's ultimately what we're trying to do. We're trying to get the x by itself. We're trying to find and solve for the solutions that can work in this equation. And so the question then for number three is negative one a solution of this? Well, just try it out, see if it works. Okay, being a solution means that it works. I want to know, does that equal 7? So this is negative 3 minus 4. I want to know if that equals 7. Absolute value of negative 7. So I want to know, does that equal 7? Absolute value of negative 7 is 7. It does equal 7. And so my answer is yes. I just want to try it out, plug it in, see if it works. Here we get into the problems, the initial idea of what this is. I'm looking at being a distance away from 0 because there's nothing added or subtracted in here, and I want to go 2 units away from that. So 2 units away from 0, I go this way, I get 2. I go this way, I get negative 2. If I plug in 2 or negative 2 for a, then those values are going to work. Well, mathematically, I'm looking for a process here. I want to go to the negative side, and I want to go to the positive side. And there's nothing else that happens here. I want to throw the word or in there. In order for me to get this to be an equation, I don't have any extra work to happen for it. Same thing happens here, except that we want to do the negative y is equal to the negative 6, and negative y is equal to positive 6. So I want everything, whatever's on the inside of that absolute value, to be equal to the negative part and to be equal to the positive part. So that's actually a negative 1 in front, so I divide by a negative 1, and I get y is equal to positive 6. There's a negative 1 in front, divide by negative 1, and y is negative 6. So it doesn't change the process if you put a negative on the inside. Okay, so keep that in mind as you're going along. Now I'm looking for, I took this y equation, whatever the function is, and I took it to the right 8. So I want to look at this in terms of, I'm starting at 8 and I want to go 4 away from 8. Well, on the number line, what that looks like is I start at 8 and I want to go 4 away. Well, that gets me to 12 over here, and it gets me to 4 over here. So those should be my two answers. Okay, so let's see. If I go y minus 8 equals to the negative, I want to go left 4, and y minus 8, I want to go right 4. Add 4 to this one, add 8 to this one rather, and I get y is equal to 4. Add 8 to this one, and I get y is equal to 12. Okay, so I can plug in those two numbers to go into my equation. Same thing happens if I have it equal to 0. I want to go 0 units away from where I started from. That's what this is saying. Well, if I go to the left, I get 5x plus 5 equals negative 0, which doesn't make any sense, and 5x plus 5 equals positive 0. When you look at those two things, they're really the same, so you only have to solve one. Subtract 5 from both sides. 5x equals negative 5 divided by 5, and x is equal to negative 1. Okay, there's only one answer from that. Well, I'm starting somewhere, so I need to find the place that I started, and I'm going no units away from that. Okay, so I should only have one answer. I'm not moving anywhere. I'm not actually going left or right anywhere on that problem. When we go to the back of this worksheet, there's one more before that. When I go to this, I can split this when I have the absolute value by itself. So don't start that way. That's not how you want to start this problem. Okay, don't just automatically jump in and do that. I want the absolute value to be by itself, so I have to subtract 4 first. So 2a plus 9, keeping in mind that ultimately what I'm trying to do here is I'm trying to get the a by itself. I need to get rid of the plus 4, I need to get rid of the absolute value, I need to get rid of the 2 in front of the a, I need to get rid of the plus 9 that's with it. So I get rid of the plus 4 on the outside. Now I can get rid of the absolute value part. The way I get rid of the absolute value is I think about going to the left from where I started. Let's erase that here. And 2a plus 9 is go to the right. So subtract 9 from both sides. 2a equals negative 10, divide by 2. A is negative 5. Subtract 9 on this one. 2a is equal to negative 8 divided by 2, and a is equal to negative 4. Now, I didn't get any fractions on these. If you get fractions, there's nothing wrong with fractions. Okay, there's nothing wrong with negative numbers that we are plugging in. Can't have absolute value equal to a negative, but you can get a negative number that you plug in, and that's okay. On this one, I have the same idea, except you have to keep in mind that when I go to the negative side, I have to flip the inequality. It's best if you flip the inequality right away, because otherwise, eventually down the line, you might end up having to flip it again. Well, you don't want to try to keep track of times that you flipped the inequality. Just flip it when you need to flip it. Okay, and so add 1 to both sides on this side. Divide by 7. I add 1 on this side. Divide by 7. Okay, now this one, when I look at these, this is going to be more important to be actually looking at and deciding what this inequality actually is. So this is a great OR equation. Okay, so I want to put an OR in between here. Now what that tells me is that, well, it tells me really what my graph's going to look like. So I've got negative 12/7 over here. You could change that to a decimal if you wanted to, if you felt better about that. But it's a repeating decimal that goes on forever. So it's fine as a fraction too. It's negative and then positive 2 over here. I've got open circles at both. I want the numbers that are less than negative 12/7. And I want the numbers that are bigger than 2. And I end up with what is legitimately an OR graph. Now, if you're asked to put this in interval notation, we're going from negative infinity to negative 12/7. And then we're going to start at 2 and go to infinity. All of these are parentheses because there's no closed circles. Infinity doesn't count anything. If you put these two things with a comma in between, I'll accept that, and that's fine. Mathematically, we want to look at that a little bit differently, but I think that we're okay right now putting a comma in between there, only because if I put the symbol that's supposed to go in there, then I'm opening a whole new can of worms that we haven't really talked about yet. And then here's the last problem. I want to get the absolute value by itself, so I'm going to subtract 12 from both sides. I've got a negative 1 in front, so I want to divide by a negative 1. When I divided by a negative, the inequality switched. Now I have the absolute value by itself. I can do 3x minus 4. Switch the sign because I made it negative. And 3x minus 4, keep the sign the same because I'm keeping it positive. Add 4 to both sides. 3x is greater than negative 1, divide by 3. Add 4 to both sides. Divide by 3. Now, at some point here, you want to start thinking about plugging this number in to make sure that it actually works. The problems that we've been doing, when you plug the number in, it's actually going to work, but keep that in mind. We've got a less than symbol, less than symbol, less than symbol, so it's an and. We want to put an and in between here. A couple things that tells us a little bit about the graph. Open circles at both of these. I've got negative 1/3 over here and 3 over here. I want the numbers bigger than negative 1/3 and the numbers less than 3. Mathematically, that tells me that I'm looking for the overlap of these. And if I needed to put these in interval notation, negative 1/3. Comma 3, parentheses at both because there's no closed circles. Okay, so there's a little bit of a difference between the interval notation and these when we have an and or an or graph. But ultimately, go through, try these problems. These are actual problems from your worksheet, so try them out. We're doing the multiples of 3.